Astronomers were not looking for a revolution. They were checking a prediction. In 1998, teams measured distant exploding stars scattered across deep space. The expectation seemed straightforward. Expansion had begun long ago, so over time it should be slowing down. The first measurements came back. Then more arrived. The pattern refused to cooperate. Those distant explosions appeared farther away than they were supposed to be. The results surfaced again, then again. Every new observation pushed in the same direction. Something was happening that should not have been happening. The universe was not easing off. It was speeding up. At first, that sounds like a difference on a graph, a small adjustment to a calculation. But the consequence was immediate. Distance could no longer be treated as a fixed problem waiting for better technology. The space between things was changing. The old assumption suddenly felt less secure. Build a larger telescope. Build a faster spacecraft. Wait long enough and eventually reach farther. The measurements suggested reality might not be cooperating with that plan. If expansion is accelerating, then what exactly happens to the destinations waiting in the distance? The first reaction was optimism. If distant regions are pulling farther away, build faster spacecraft. Give future civilizations enough time and enough technology, and eventually the gap can be crossed. Then the implications of acceleration started to unfold. Some galaxies were not simply sitting at enormous distances. They were being carried away by expanding space itself. Picture a destination marked on a map. Decades pass. Centuries pass. The destination is still there, but it is drifting farther away the entire time. Wait longer, and the journey becomes harder. Wait long enough, and the trip stops being a matter of engineering at all. The unsettling part was not that the target moved, it was that delay itself became a loss. A civilization that leaves earlier has more options than one that leaves later. A civilization that waits inherits a smaller future. The old assumption depended on opportunity accumulating over time. Better technology, better engines, better solutions. Acceleration reversed part of that logic. Time was no longer just providing new capabilities. Time was also removing destinations. Not because the galaxies disappeared, not because anything blocked the route, because every passing year carried some distant regions farther into separation. Exploration was no longer limited by engineering alone. The list of places that could someday be reached was quietly shrinking. And if opportunities can vanish simply by waiting, an uncomfortable question follows. How much of the universe has already slipped beyond humanity's future reach? A solution still seemed to exist. Maybe reaching those distant places would become impossible. Maybe no spacecraft would ever arrive. But exploration had never depended on travel alone. The galaxies were still visible. Point a telescope toward the sky, and the light kept arriving. Night after night, year after year, signals continued crossing the darkness and reaching Earth. The destination might be beyond physical access, yet information was still making the journey. That changed the mood completely. A ship does not need to land somewhere for knowledge to survive. Telescopes can collect images, spectra can be measured, observations can be compared, questions can still be asked. The destination was gone. The information was not. What had looked like a shrinking future suddenly seemed manageable again. The loss was real, but it appeared limited. Humanity might surrender the ability to visit certain regions, yet observation remained intact. The universe could still be studied even when parts of it could no longer be reached. Exploration was changing form, not disappearing. The destinations stayed beyond reach, but the evidence continued arriving. And as long as the evidence kept arriving, it was easy to believe that nothing essential had actually been lost. The reassurance did not last. The galaxies were still visible. Their light was still arriving. Telescopes still worked. But acceleration was affecting more than travel. Imagine watching a distant galaxy through a perfect instrument. New stars form, old stars explode. Entire chapters of its history continue unfolding. The galaxy keeps changing. The problem is that its future updates do not keep arriving forever. As separation continues increasing, there comes a point where new light emitted from that galaxy never completes the journey back to the observer. Nothing breaks. Nothing blocks the signal. Nothing destroys the galaxy. The events still happen. The information simply never arrives. A telescope pointed at that galaxy would continue receiving older light already on its way. The image remains. The galaxy remains. Then something subtle happens. The stream of new information stops growing. The observer is no longer watching an active connection. The observer is watching the last updates that managed to get through. Beyond that point, the galaxy continues its existence alone. New stars can form there, new events can occur there, entire future eras can unfold there. Yet none of those future chapters ever reach the observer again. That realization shattered the remaining sense of safety. Observation was never a permanent backup plan. The same process that removed destinations from physical reach could also remove their future history from observational reach. No ship could get there. Eventually, no new information could get here either. The galaxy survives. The connection does not. And if entire regions of reality can remain physically present while their future history becomes inaccessible, what exactly is left for future civilizations to inherit when the evidence itself begins disappearing? Humanity happens to look out at the universe during a remarkably unusual moment. Distant galaxies are still visible. The evidence of cosmic expansion is still visible. The observations that revealed acceleration are still available to be collected and compared. The sky is providing multiple pieces of the puzzle at the same time. That will not always be true. A future civilization may build instruments far beyond anything that exists today. Larger observatories, better detectors, more precise measurements. Yet superior technology cannot recover information that never arrives. Some destinations are already beyond physical reach. Some evidence is already moving toward disappearance. Future civilizations may inherit better technology than ours while knowing less about the universe than we do. The discovery made in 1998 was more than a measurement of how the universe behaves. It exposed a limit that grows quietly in the background. The frontier is not standing still while humanity prepares to explore it. Parts of reality are leaving at the same time they are being observed. The galaxies continue existing. Their history continues unfolding. But access to them, both physical and observational, becomes less complete as time passes. The universe remains exactly where it is. The galaxies remain exactly where they are. What changes is access. Some destinations can no longer be reached. Some evidence will no longer arrive. The frontier is not disappearing because humanity failed to cross it. The frontier is disappearing while humanity watches.